Okay, good morning. Okay, welcome to lecture for week 5. Last week we have our term test. The term test results, you should be able to see your marks by October 11th. We have finished marking, so now we are waiting for, there's some student that have to do some correct. So if your student number is listed on Avenue to Learn, and I ask you to correct question 1 or question 2 or question 1 and 2, okay, your due date is tonight to do your corrections. Okay, class average, just to let you all know, class average is about 61, which is really good. Highest mark was about 85%, so a few students got A to A plus. Okay, and there will be a quiz number 4 on this week's topic. The due date is October 15, okay, at 2359, okay. So anyone, any questions after I mentioned all this information? Anyone? No? Okay. So the first thing we are going to do is, by the way, in the term test, the topic on the shearing stress, a lot of you did really well, which I'm so happy, okay. A lot of you really did well, okay. So today we are going to look into two topics still under shearing stress, and one is shearing stress in thin wall, and the other one is longitudinal stress. Now this topic, again, you have to obey the 4 rules that we have written, okay, for shearing stress on week number 3. The rules still stand. I'll introduce you a new one, okay. Just one more rule that has to be implemented in shearing stress in thin wall. Okay, so here we go. So we're going to look at shearing stress in thin wall. Okay, and shearing stress in thin wall, there are 2 configurations. So one is known as box beam, and the other one, the second one, is called wide flange. Okay. So on Avenue to Learn, I've posted some images, okay, that I will use today. Please go to Avenue to Learn to get all these images, okay. So I'm going to get the image. So the first image over here, this is what we call a box beam. Okay, so as you can see down here, this is known as a box beam. And the second figure, that I'm going to show you down here, this is known as the wide flange. Okay, so you have 2, and I'm pretty sure you can distinct the difference with either one of them, right? So a box beam is very obvious, it's enclosed like a box. A wide flange, it look like eye or a open structure. Okay, so there are some terminology that I want you that I'm going to introduce. Okay, so if you look over here where the start of the arrow, okay, right, these are known as the not arrow, sorry, the start of the flow stress. Okay, and when the flow stress come together, this is also a terminal, right? So that's for box beam. For wide flange, the terminals are over here. Okay, so these are known as the terminals. Okay, so the dot region are known as your terminals. Okay. Now, the common with both of these, there's a common feature. And this common feature get us to write what is rule number 5. Okay, rule number 5. Before I state the rule number 5, all these arrows you see are known as the shear flow, are known as what? Q. You can see here, right? You got Q1 and Q2, all these arrows you see. And the length of the arrow you can see the arrows at the terminal, it is short, and then when you move further away from terminal, it gets longer. You can see that, right? So the length of the arrows determine the magnitude of the shear flow Q. Okay. So what I'm going to specify here is this now. Okay. So we have rule number 5 is the web, right? The web controls the shear flow direction. So by looking at these two figures, let me elaborate what's going on, okay? So we know that these two parts, they are known as the web. For this case, this is known as the web also, right? So the main web, the major web, goes, the shear flow starts from the top to the bottom, yes? Likewise, for the wide flange, it starts from the top to the bottom. Now, why that is important? Okay, why that is? So this is how you construct your shear flow. Okay, so now if I'm going to sketch our box beam without a shear flow, right? So this is our box beam, right? And then we have our centroid, right? Then we have our V, right? So the first thing we do when we construct the shear flow, right, is the what? We apply rule number 5, right? The web controls the shear flow direction. So because V is coming from the top, okay, so this is how your shear flow comes down. Right? And I'll elaborate one more thing, okay? The fact that it's known as shear flow, it is very similar to what? Fluid flow, okay? Right? So let's think like you have water coming down from the web, from vertical on the web in the box beam, right? So it's natural to construct your shear flow in this direction. The shear flow will go towards the left and right, and then from the right to the left back at the bottom part. Okay, so that's how we construct our shear flow. So if we now go to the wide flange, okay, so we construct the wide flange. Same idea. The first thing you do is you apply rule number 5. Okay, so this is still our V. Right, so you apply rule number 5 is the shear, the web control the shear flow direction. So this is like the major highway, okay? It's always that direction. So when there's a case, you have this. So this is how you construct the shear flow, okay? Now, the next thing is, what is the difference between thick wall and thin wall analysis? Okay, so remember, this is thin wall analysis. So what is the difference? Okay, so I'll write down the difference for you now. Okay, so let's say if you want to find the shear flow, okay, the shear flow at this point, right? The shear flow at this point. The thickness is perpendicular to the shear flow direction. Okay, I repeat again, the thickness, right, is perpendicular to the shear flow direction. So if I want to find the shear flow at this point, okay, or sorry, at this point over here where I'm circling now, right, this is the thickness. Okay, so in summary, in thin wall analysis, the thickness right, T is perpendicular okay, perpendicular to the shear flow arrow Q. Okay, so now let's look at the difference between thick wall and thin wall analysis. Okay, so let's pick a common thick wall analysis. So we are going to do thick wall analysis now. Okay. Okay, for simplicity, I will take the I beam. Okay, let's look at the I beam. Or T beam. Okay. Or let's take the I beam. Okay. And I'll show you some difference and similarities. Okay. Let's look at the difference first. Okay. So now we construct our shear flow. Thick wall, there's also shear flow. Okay. Only I'm not asked you to construct them yet. So this is how the shear flow will flow for thick wall. Hey, what am I doing? Hey. Okay. Okay. So for thick wall analysis, right? If I want to find the tongue twister, I want to find I'm interested in A. What is the shear stress at A? So the area of concern is this area. Okay, the area of concern is this area now. Right? That's thick wall. This is what we've been doing. And the thickness is this is the thickness. T. Okay. But if we do thin wall analysis, okay, so same point, okay, so below I'm going to write thin wall analysis. Okay. Now what we have, I think I better draw new.